Just write down. Whatever I can write down and just try to bring it in tomorrow.
All right, your first question on that test there is typical TP sensor voltage at idle is about
B.
Yep.
0.5 volt.
Now typically on a GM product it would be a half a volt, and on a Ford it'd be closer to 1. The funny name that they call this thing TP sensor used to cause one of the parts guys at Bondi used to call it a wigwam indicator. What I thought was kind of silly, because a TP and a wigwam is about the same thing. A TP sensor is, I'm asking, are we on the right test here?
We are.
TP sensor is what type of sensor?
C.
That's a potentiometer. Very easy question. We talk about TP sensors a lot. After a TP sensor has been tested using the min-max function of a digital multimeter, a reading of 0 volts is displayed. What does that mean?
Both B and C.
D.
Is the TP sensor is shorted, or what?
Yeah.
That would be
Shorted.
Define shorted, Greg. If somebody was going to tell you, what does it mean when something's shorted, what would you mean? What would you think?
Means just half size.
It's what?
Half size.
Half status.
Half size.
Well,
Let's say it's got an open circuit somewhere.
half size. So if it was, what you're saying was it made the short list, huh? No, if it's shorted, then see, we got, remember this, we got a wiper, and you got, this is actually, all three of these are going back PCM. But basically you're going to say this is ground, and this is VREF, and this is your signal. Now if it's shorted, there's something that has either got these two touching one another, or something that's got these two touching one another. That's a short. I need to clear that up, because people are always saying, everybody wants to say it has a short in it, and it has a short in it. Well, if it's a short, that means something's touching something that's not supposed to be touching. That's what that means. If it's an open, it means that, and actually I left off the little wiper when I drew this. If it's open, it means that the resistive paint is rubbed off, and you don't have a complete circuit at one point. So an open is like you've cut the wire, and a short is like two wires are touching.
Oh, okay.
You see what I'm saying?
Yeah.
If you got a wire that's touching the body of the car, that's a short. If some yo-yo has come over here and has got his side cutters and has snipped it, or if the belt has cut the wire and it's in two pieces, that's an open. So to identify whether it's a short or an open, and everybody needs to be able to do that.
I know now.
Yeah. And if, I was kind of amused by Greg's answer when I said if a TP sensor is shorted, he means it's not as tall as another TP sensor, right? Okay.
That's pretty good, Greg.
Yeah, Greg was trying to be comical there on that, and he was pretty comical. All right, now then, but now let's go back to question 3. After a throttle position sensor has been tested using the min-max function of a digital multimeter, and what is that min-max function? What is that about? Anybody done that before?
No, I ain't.
You remember the fuel pressure reading on our? I got this little digital fuel pressure gauge, and you push the button, and it gives you the lowest that it has read, and then it gives you the highest that it's read, and then it'll give you what it's reading right now. So you've always got 3 different parameters that you're going to be looking at on that. Right? If, let's say you've gone through there and your TP sensor voltage, let's put it on a graph. Let's say your TP sensor voltage started out at, let's say 0.5, and at the top of the scale, you're going to be seeing 4.6, right? And let's say that you started out going up, and then you came back down, and you let it come back again. All right, what you did was you got it to about 1.3. All right, at that point, your meter would read that the minimum had been 0.5, and the maximum had been 1.3. But what if it did this? What if you were going up, and it dropped out, and then it went up, and this was down here at 0? Now the meter's gonna tell you the minimum was 0.0.
Oh, okay.
The current, if you've got it, you know, whatever it's reading now is what your current's gonna be.
Okay.
The maximum is gonna be the most that it has read at any time during its sweep.
Mm-hmm.
All right, so this maximum is gonna change as you go back up again with it. Well, now when you go back and look at your maximum, it's gonna say 3.8. So that's as high as you went. So why is that useful? If you think that that thing's dropping out or there's something crazy going on, your minimum current maximum, it's just giving you the numbers. You push a button, it gives you, it'll say MIN. That means this thing has gone as low as 0.2 of a volt. But right now, when you go push it again, and it's giving you what it is right now, then that's giving you your live voltage. Okay, your maximum, both of these, the minimum and maximum are stored values. You know, which can either, if you've had it for a long, if you've cleared it, and you can clear your minimum current and maximum and start over. See, if I'm driving down the road and I'm looking at my throttle position sensor voltage, I want it, and I've gone from idle to half throttle to wide open throttle and back and all that, and I have felt it buck and jump a couple of times. All right, then I stop beside the road. I put it on my, I get my meter, and I go to the minimum current and maximum, and if I see that minimum went to 0 at some point during that drive, I feel like I've got a throttle position sensor voltage signal that's become unpredictable and it's dropping out, and that's causing the computer to think I let off the gas, and so it changes things like I let off the gas. See, that's not really all that complicated. But anytime my fuel pressure on minimum current and maximum, I got two. On that other thing, see, like, let's say that my on Ben's truck. Ben, your truck running okay now?
Mm-hmm.
Your white one that we put the fuel pump in and all that?
Yeah.
No more problems, right? Remember when we snapped the throttle on Ben's truck and the fuel pressure went down and then up? Remember that? Mm-hmm. Okay, if we'd had that minimum current maximum thing on there, and we would have seen, what was your fuel pressure, Ben? Normal, you remember? 45 pounds, wasn't it? Okay, so so what we would do on that one, we would pull our vacuum line from our fuel pressure regulator, and we'd notice, and we would clear the minimum current and maximum information so everything is starting over. And we're going to see 45 pounds. Okay, we snap his throttle, and his pressure drops and then comes back up, which is what was wrong with his. When we pull that fuel pressure regulator vacuum line off and we snapped the throttle and the pressure fell about 10 pounds while we were snapping it, that right away told us we had a weak fuel pump because we'd already replaced the fuel filter.
Yeah.
Well, your fuel pressure gauge would have reflected that when you snapped it, the minimum was like 32 pounds when it should have stayed even at about within a pound or two of 45.
Oh, okay.
You see what I'm saying? All right. Now then, let's go here to the next question here. So, well, let's look at here again now. Minimum maximum function on DM, and a reading of 0 is displayed. What does this reading indicate? That it's open at one point during the test. That's basically what it is. At one point during the test is the key. Got it? All right. Now, why is B wrong? In other words, the first one is the TP sensor is shorted at one point during the test. B says the TP sensor is shorted. Open at one point during the test. B says it's shorted. It's going to read 0 all the time, isn't it? Or it's going to read 5 volts all the time. The TP sensor signal is shorted to 5 volt reference, or both B and C are possible. Neither one of those are right, because what you're talking about is just at one point. That's what minimum maximum is about. A technician attaches one lead of a digital meter to the ground terminal of the TP sensor, and the other meter lead to the negative terminal of the battery. You got that? One lead of the digital multimeter to the ground terminal of the TP sensor, which is your signal return, right? And the other meter lead to the negative terminal of the battery. The ignition switch is switched on and off, and the meter displays 37.3 millivolts. Technician A says this is the signal voltage and is a little low. Technician B says the TP sensor ground circuit has excessive resistance. Which technician is correct about that? That's question number 4. Ben? Which technician is correct about? Where's your book? You got to flip your book over there. What's the matter with that? Anybody got a good answer for that?
Would be neither, because you have to be in parallel to measure voltage, don't you?
Yeah, you're actually measuring from ground to ground, right? Okay, so if the ignition switch is switched on, engine off. In other words, he's not actually cranking the engine, he's just turning it on. And he's reading 37.3 millivolts, which is not very much. If you take 1 millivolt and you multiply it times 1,000, you've got a volt. That's just a tiny little bit. So that's not the signal voltage, is it? It won't be if you're measuring the ground side of the sensor. The TP sensor ground circuit's got excessive resistance. So, is he right? You're not really supposed to see anything there. But I'm going to tell you something. Anytime you've got connections in a circuit, you're going to have a little dab. He's actually measuring voltage drop. Okay, let's look and see what he's doing here. Am I wearing y'all out? All right. Okay, right here, you got minus, you got plus. Okay, right here, you got PCM. All right, we're just going to draw 3 wires for the sake of our argument here. All right. Okay. Now, that's your TP sensor. Okay, TP, and this one right here is VRAF, and that one right there is sig return. That one right there is signal return. This is what we're checking. All right. Now we've got our negative terminal. Obviously, this PCM is going to have a ground that's connected to here, right? Now, what are we doing? Look at here. If you just hand Ben answers on a silver platter, he turns in the test, but he don't learn anything.
Oh, I was telling him it's actually in chapter 12 instead of 10.
Make a blue mark on your nose with my marker. That's what I'll do.
Greg
All right.
figured that out.
Now watch this.
Yeah, Mr.
See this?
The wrong test on here.
Look at what I'm doing with my meter, because we need to be able to tell this. See this? I'm going to hook 1 meter lead here. I'm going to hook the other one right there. All right, I'm reading 37 millivolts. Now, what you're saying is the answer key, I'm going to tell you why the answer key wants on 3. I'm sorry, on 4, question number 4. The answer key wants B. Excessive resistance. How do we know by reading millivolts that we've got excessive resistance? Is this a voltage drop test between the ground here that's coming out of the PCM and there? It has to be. That's the only way that you're going to. But 37 millivolts is such a tiny amount. You have the key on, right, where current's flowing everywhere, and you're measuring voltage drop. And look at all of this connection between here. You've got connections in here on the circuit board. You've got to come through some stuff coming out here. You've got a connection here. And then you've also got all the connections between here and here. Don't you think you're going to have a little bit of voltage drop there?
That's what's throwing me off, because that's a little resistance, but it says on B it says has excessive resistance.
Yeah, I don't really see a whole lot of a problem there. I'm telling you, if I measured that, I would think I am wasting my time measuring voltage drop on this circuit. What I'm basically going to do here is I'm going to take and see if I've got, a good ground there. I measure between positive and there. If I got a good ground there, I'm not going to, take my meter and measure and see if I got a good ground there. I'm not going from here to there to measure voltage drop when I think of there's too much in between there that can make a little bit of voltage drop, and that's 37 millivolts. Now, if you want to get that one right, according to the answer key, whenever it's graded in there, you're going to put B on there. I'm going to say neither one of those guys know what they're talking about. That'd be my answer to that question, but I don't like the fact that, I do not like the answer to 4. Don't like it. But, I didn't write the book. Not this time. I might one time, but I didn't this time. A P1022 diagnostic trouble code is received using a scan tool. That diagnostic trouble code means what?
The TP sensor voltage is low.
All right. Well, does it mean that? What do you think?
Shorted the ground.
TP sensor could be shorted to ground. Now, see how silly that question is written. if the TP sensor voltage is low, they would mean that, what would that mean? What's it supposed to be ordinarily at idle,
0.5.
roughly? Okay, so if it was 0.3, that wouldn't be a short to ground necessarily. I mean, you know, I guess you could make a case for anything. The answer key on that one wants B, but the TP sensor signal circuit could be shorted to ground. Well, what in the Sam Hill is, I mean, it sounds to me like B or C, either one could be right. Sounds to me like D ought to be the right answer on that one, doesn't it to you?
That's what I was kind of thinking. Then you look at the chart on page 245, and it just says TP sensor voltage or TP sensor low voltage.
Mm-hmm.
But
And see, look at, and that's crazy too, because your book is indicating that you ought to be able to put A on there and get that question right, doesn't it?
Mm-hmm.
Wouldn't you be right about that?
Yeah.
But then, if the TP sensor is shorted to ground, though, won't the voltage be low?
Yeah.
If the TP sensor signal circuit is shorted to ground, won't the voltage be low? All right. So 5, I mean, if I was going to do it, I'd make sure 5 was D, right? Wouldn't you say that? Dog, delta, all of the above are correct. I think any of those could be correct. That is a poorly written question. And
But the correct answer is B, though.
the correct answer according to that, but I'm actually changing the answer key to delta. That's what I'm doing there. Okay. All right. Now we're going to go with number 6 now. 2 technicians are discussing a stepped engine coolant temperature circuit. What in the world is a stepped engine coolant temperature circuit? Can anybody tell me what a stepped engine coolant temperature circuit is? Have you ever seen a stepped engine coolant temperature circuit? Has anybody here ever seen one?
Probably just remove the wood.
Okay, you remember last Wednesday, if I remember right, we went to the shop and I took up this potentiometer out there on that Oldsmobile. And I was measuring voltage on the TP sensor. And as I dialed the resistance down on the TP, not TP, on the engine coolant temperature sensor, as I dialed the voltage down, it came down.
And it jumped back up because it has to.
Exactly. If we drew it on a graph, it would start out here, and it was going down, and it got down to about just below a volt, and then it did this. It shifted gears, and then it went down again. That's what that looks like. Now, you don't typically see that. You see it on General Motors cars, and you can see it on some Chrysler vehicles. You don't typically see it on a Ford. But you're actually seeing a lot. See, on a Ford, if you did a temperature deal, if you went from, say 70 degrees to 200 degrees, you're going to see a voltage sweep on this GM look like that. Now, when it gets to a certain temperature here where it's almost at the bottom of the voltage scale, with this being, 0 to 4.6 or whatever, well, actually, 4.6 would be higher than that because it's not going to start at 4.6 when it's at 70 degrees. And it actually comes down to almost 0. It's going to jump back up and then go back down. All right. Now, who saw that and remembers it? JT did, I think.
Yeah,
Does anybody else remember seeing that?
I remember seeing
Do I need to show you all that again? Because we're going to burn it in. I mean, whenever you're looking at it on the scan tool, it's typically just going to give you, some of them will give you voltage in. All right. On a Ford car, you're typically going to see something that looks like this. That's what you show on a Ford car. It looks like that. It's a lower slope, and it just goes from 3.8 or whatever down to about 0.6 of a volt at 200 degrees, or actually slightly more than that. So anyway, technician A says the sensor used for a step circuit is different than the one used for a non-step circuit. Is that true? Technician B says a step DCT circuit uses a different internal resistance inside the PCM. Somebody needs to know the right answer to that without guessing at it like JT was just doing. do we have a different sensor, and do we have a different circuit inside the PCM?
Probably just the circuit inside the PCM sounds like. Because the PCM's telling it to jump back up the volts once it gets down to a certain resistance.
Where is this information located at?
Check 12.
Yeah, I've got like the TP sensor stuff, but I'm not seeing anything on it
You're not seeing anything on engine coolant temperature sensors?
unless I'm overlooking it.
Flip to the next chapter. See if you see engine coolant temperature sensors in there. Because I think that may be where you need to be for that. Nope, that's Mount Barrow. What, now, wait a minute. You're on, Ben, where are you at?
Just
Look at chapter 11. What is chapter 11 giving you on that?
Okay, that's
ECT.
different.
Yeah, that's going to be your temperature sensors in chapter 11.
50.
You got it? All right, watch that. All right, now the correct answer to that, and you're going to read it in there, is both of those guys are right because we have a different sensor and we've also got a different circuit inside the PCM. So the PCM is wired different internally for that step circuit, and the sensor is a different one too. So number 6 is going to be C. You get that? When you're testing an engine coolant temperature sensor on a vehicle, the digital multimeter can be used and the signal wires backprobed. What setting should a technician use to test the sensor? When you're testing it on the vehicle and you backprobe the sensor, what should you put your meter on? AC volts, DC volts, ohms, or hertz?
DC volts.
You said, what did you say?
DC volts.
DC volts. Okay, let me ask you this. Under what circumstances would I be measuring AC volts? I mean, on what sensor would I use? What about, and y'all have done it, you remember on your, when I had you do that exercise, the vehicle speed sensor, anything that's a speed sensor will typically be an AC volt signal because it's going to have that magnet with a wire wrapped around it. It's variable reluctance is what they call it. And those little teeth go whipping past there. The voltage goes above and below zero. So that's going to be an AC signal. All right, like right here. See that sensor I'm pointing my laser at right there? If you were going to measure that one, the crank sensor, you're going to measure with AC volts. And as you go up with your speed, the more, the amplitude and the voltage changes. And the amplitude and the frequency is going to change with speed. And then what about ohms? If I decided I wanted to measure that ECT sensor using ohms, what would I have to do in order to get a good reading?
And the meter to ohms.
And set your meter to ohms is a good answer, but that's only part of the answer. What else do I do?
The ohms and then disconnect it from the motor?
Disconnect it from the sensor.
From the sensor.
You can have the sensor in the motor, but you got to disconnect the wires from it. Got that? Okay, now
But the wires have their own ohms.
Now, what is hertz?
Hertz is frequency.
Okay, so what sensor would I measure with hertz?
You measure
I mean, there are sensors on vehicles that put out hertz.
Hall fix sensor?
No, well, that's not going to measure those with hertz and get any good out of them. There's no reason for that. You're actually going to measure the map sensor on the Bronco.
Okay.
It measured hertz. It reads 110 hertz with the engine running and about 158 hertz without the engine running. Now, just a minute, mass airflow sensors on some of the GM cars and some of the Jap cars have got a hertz reading that you're going to measure with those. What?
Yeah. My test is gone. Tyler don't got it. I take all my tests and set them on this table. All the other tests I have are either right there or right here.
Your 10?
It's gone. Somebody got it off the table.
Well, you probably ought to put them back over there instead of leaving them spread all over the table.
Well, I mean, where they're on this table, I know where they're
And
at.
that would help you out with that. Right, just a minute. But whenever you you can't really stake claim to the table the whole time like high school students coming and going and all that kind of stuff, So if you keep up with your test, you probably ought to put them in your bin or something instead of throwing them all over the place. There's all kinds of papers on the floor
Yeah,
out
just
there.
put those there.
Yeah, right.
Put them there,
Yeah,
keep
we
them off the table.
don't want footprints on those.
And I bet it was Highland, because he took all the rest of my books and wrote his name on them.
Who did that?
Highland?
Well, if they're just kind of laying around all over the bench, he may have thought they were his. All right. You got that? So you're going to put DC volts on there. B is the right answer to number 7. When checking the engine coolant temperature sensor with the scan tool, what temperature should be displayed if the connector is removed from the sensor with the key on, engine off? Key on, engine off. Connector is disconnected. What you going to read? There's a caveat to this question that I got to hit y'all with too that I've already talked
Oh, it's
about.
negative 40?
Yes, unless
Unless
what?
the sensor's messed up.
No. Unless you are. Remember what I told you?
Sure.
You got OBD2 and you got enhanced. If you go into OBD2 room, the regular OBD, the OBD2 global, you're going to find 40 below in there. But if you go into your enhanced, it's going to substitute something like 110 degrees. So you're liable to see, if you disconnect it and you're in the enhanced room on your scan tool, you're liable to see a substitution that it puts in there that it feels like will probably work. See, if it knows if it's reading 40, 45 degrees on this engine coolant sensor and it's reading 40 below on the other one, it knows that 40 below one is not accurate. And so it's going to say, well, I know that if I put 110 degrees there, it will probably work. If the programmer set that up. Okay, so your enhanced room is going to reflect what the computer is actually substituting. On the OBD2, it's going to give you the 40 below number. See, so there's times when the OBD2 global is a better place to look because it's less confusing. Like let's say this. Let's say that the temperature outside was about 100 degrees, and you had a code for an intake air temperature sensor, and you go into your enhanced part of your scan tool, and you're seeing engine coolant temperature is at 180, intake air temperature is 110. You're going to say, well, I don't really see anything wrong with that. Why is it throwing me a code? But if you backed out of there and went into your global OBD2 room, you say 40 below zero. Oh, crap. It's brought a broke wire between the PCM and the intake air temperature sensor. See that? So that may be one of the things that I do on one of the, what I need to do on these 5 or 6 vehicles that I set up for your final exam where you have to fix them all in a given amount of time is go through there and snip a bunch of wires up in the harness somewhere where you got to find those where it's not as easy as just something that's unplugged, right? Is that a good idea, Ben? All right, then. Okay. You ought to read 40 below. That's going to be, it shouldn't read 284, 230, or 120. It should read 40 below. You're looking at the scan tool OBD2 global. Remember that. A typical intake air temperature or engine coolant temperature sensor reads about 3,000 ohms when tested using a digital multimeter. This resistance represents a temperature of about
120 degrees.
Yeah, you just about would have to have a table on that, wouldn't you?
Yeah.
9. This represents a temperature of about. You got a table over there somewhere? Look at number 9.
Yeah.
What is it?
Or you said, how much is it say? 3,000 ohms?
3,000 ohms is
About
equals.
122 degrees or 50 degrees Celsius.
Okay, that's going to be a C, isn't it?
That's right, like 3,300 degrees.
What page are you on?
33.30.
Yeah, that's going to be a C. All right. A PO 118 diagnostic trouble code is being discussed. Technician A says the engine sensor could be internally. Technician B says the signal wire could be open. Who's correct about that? What's a PO 118 mean? You got a code for that down there?
ECP sensor high voltage.
Doesn't look like it's unplugged or something? Or like the wire's cut? Is that right?
It says that it's open.
Oh, yeah, that's why. Like if I reached in there with my side cutters into the wire harness and I cut the wire,
Yeah.
it'd be open.
It could be internally shorted too.
Well, now wait a minute.
Could be.
That's going to be a different code.
Yeah. And
And the reason, let me tell you what you do then. Watch this. Let's say you don't know. I mean, let's say that you got a good sensor, you got a good connector, there's nothing wrong out here, it's not unplugged. You go to the PCM, you check the pins there, you make sure they're not pushed back, unplugged, whatever, poor crimp or so on and so forth. And let's say somewhere in the harness it's cut. How am I going to determine if somewhere in the harness it's cut? And this is something else I want to hit you with, and I've got to talk about this right now. Y'all don't feel like you're being persecuted because I'm talking a long time in the classroom, because this is big time good stuff. All right, we got signal return, which I like to call it that myself. And we've got, over here we got VREF. All right. Now then, that's plugged into the sensor. We've unplugged the sensor, so the sensor is disconnected, right? All right, so we got the sensor disconnected, and we got to read what in voltage? 4.6 more or less, right? Typically, about 4.6. I mean, actually, when we disconnected one of that old mobile, I think it was reading 5 volts or something like that. But the fact is, we're going to call 4.6 disconnected and 40 below. The hotter the sensor gets, the more you short those wires together, it's going to go. All right, if it sees this, you're getting a P0118, right? Am I right? Got that? P0118 is shorted. Okay, now, a bunch of different things could cause this. Let's say the sensor is plugged in and you're getting a P0118. Okay, all right. Then we got a little bulb there. All right, the sensor's plugged into the PCM and you got a P0118, which means open circuit. Let's say at your PCM, and you're on your scan tool, you're reading the 4.6. If it's giving you engine coolant temperature sensor voltage, there's a reason why they show you that voltage, right? All right, you need to know what to do. What's the quickest way you're going to find out? Let's say that somebody's already gone to AutoZone and they've already put a sensor on there. And you're saying, well, I need to know if this is what kind of problem this is. So why don't I do this? And y'all watch this. Don't be bored with what I'm saying or you ignore what I'm doing, okay? I'm going to take a jumper wire with my sensor disconnected and I'm going to do this. Now what's that going to do? It's going to throw the opposite code. Because the code for an open sensor is different from a code for a shorted sensor. Just because your coolant temperature sensor is not quite looking right, the PCM ain't going to throw you the same code for everything. You understand what I'm saying? This is engine performance 2 now. We got to get into this deeper than we did before. So if I do this and I see 4.6 volts, what do I know? If I've jumpered that and I still see 4.6, now what does that mean? Hey Johnny, what's up?
Hi, that gearbox thing gonna be here till like 2:30 today.
Johnny.
Okay, can you hang around until 2:30 and then pick it up and bring it to me?
Yeah, I can. I didn't know if you wanted me to.
Just keep working until 2:30 and then grab the gearbox and head this way.
Me and Jimmy's back here watching videos.
Oh, please. Give me a massive break. All right.
We're taking classes.
Okay, well, I got me a class too going on, so I will be talking to you later. Okay, and I'm also going to see what? You got a list of your codes in there for a shorted ECT sensor? Is that what you said?
PO 117.
PO117. Ah, here we go. That's what we ought to see. We ought to rerun our test and we get a code PO117. What do we know now that we didn't know before?
That's not internally shorted.
We know a couple of things. We know that in all likelihood, if we get the opposite code and our voltage goes high, we know that it's got to be the engine coolant sensor. That's all it can be. See? Because even though they put a new one on there, they got a bad one. And the way you know that is, I've actually checked this connector, I've checked these wires, I've checked the PCM with that one simple test. I've already done that. Unplug this, jump it, run your test, you get a 117, you know your sensor's bad. End of story. No problem. Got it? You understand what I'm saying there? That's how you do that. If you try to make that, that's what they teach at the factory schools now. You try to make it do the other code, like the old 2-digit codes that we used to have on your TP sensor. A 63 meant the TP sensor was open. A 53 meant that it was too high. In other words, I say that. Excuse me. This meant low voltage at the TP. That meant high voltage at the TP. So whatever code you got, you're going to try to make it do the other one. If I'm getting a high voltage code, I'm going to jump signal return to signal. And if I then get this, then I know I've got voltage reference shorted to, the signal wire. Anyway, One way or another, you're gonna check it that way. And this is all common sense. You can figure this out if you're fighting with one and all that. All right, so just keep that in mind. Now then, what I was saying, ECT sensor could be shorted internally if it's got a PO 118. Is that true or is that false?
False.
Well, if it's a 118, you got low voltage, right? Or is that high voltage? It's false because that is a high voltage, right? That's like it's disconnected. That's like the 40 below thing. Okay, the signal wire is the one that feeds the voltage out to it. There's only 2 wires going to that sensor. So if the signal wire is open, could that be the cause?
Yes.
That's going to be a BOFM, isn't it? That's basically, if your PO 118 means that is that, so both of them could be right. I tell you what, I'm finding more errors on this answer key on this particular test. That's the weirdest thing I've ever seen. See, that one there should be C. I found 4 wrong answers on this answer key so far. It just irritates me about this particular test here. You got that? Okay. There we go.
Can we get some more PV blaster put on them at Zoscope?
Yes, I've got some in my office. Yeah, I'll pick you up with some.
Hey, look, what's 4,000?
You can figure that one out. That one, that particular one there.
This means both are together.
That was actually supposed to be being number 4B.
What's that?
Is what the answer sheet said.
Okay, it's got us. That was an S.